Let's practice applying our understanding of how to divide fractions to a few different application problems together. Now, to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. For number one, we see that the area of a rectangle is going to be 9/4 square meters, and the width is going to be 3 3/4 meters. We have to go ahead and determine the length of this rectangle. So keep in mind that when we're dealing with rectangles, we can use this formula for area, which is area is equal to the length multiplied by the width. Now in this case, we do know the area and we also know the width. We just have to find the length out. So to find the length here, we could also say that the length would be equal to the area divided by whatever the width is going to be. All right, so let's see. To find the length here, let's just kind of keep this L for length. The area is going to be 9/4. So typically we like these improper fractions when we're dividing. And we're going to go ahead and divide by the width here, which is going to be 3 3/4. Okay, so when we divide fractions, keep in mind that we do like the improper version. We don't really like this mixed number here, so we can go ahead and rewrite that as an improper fraction. So if we keep this 9/4 the same, let's go ahead and divide this and turn this 3 3/4 into an improper fraction. So 3 times 4 is going to be 12. 12 plus the 3 is going to be 15. So we're going to divide this by 15/4. Okay, so when we're dividing fractions, keep in mind that we can rewrite all division fraction problems into a multiplication problem. We're going to go ahead and use this KCF acronym, or keep, change, flip. So we're going to keep this 9/4, change the division to multiplication, and then flip the 15/4, or write the reciprocal, which is going to be times 4/15. All right, when we multiply fractions, what's nice about it is we can just go ahead and multiply the numerators together. So if we multiply 9 times 4, that's going to be 36 for the numerator. And then for the denominator, we just have this 4 times 15, and that's going to be 60. Okay, now we have this fraction here, and that is going to be the length of it, of this rectangle, but I think we can go ahead and simplify this a little bit. So let's go ahead and use the ladder method to help us do so. So 36/60, let's go ahead and see what common factors we could divide these both by. I'm going to go with 6 first, because 6 times 6 is 36, then 6 times 10 is going to be 60. Now between 6 and 10, I think we can divide these both by 2. We're going to be left here with 3 and 5. So we're going to go ahead and see what the greatest common factor is. It's going to be 12 here, right? 6 times 2 is 12. So we can divide both the numerator and the denominator both by 12 to simplify this fraction. And if we do that here, we can see the length is going to be what we're left with at the bottom, which you can see here is going to be this 3/5. So the length of this rectangle must be 3/5 meters. So that right here is going to be our answer. So in summary, we can say that the length of this rectangle must be 3/5 meters. If you want to go ahead and check this, you can go ahead and take this 3/5 that we got for our answer. If we go ahead and multiply that by the width of 3 3/4, you should see that we do get 9/4 square meters for the area. Okay, so you can always check it by multiplying the length and width just to confirm that it does equal the area. All right, so for number 2, a bakery has 42.5 cups of flour to make pastries. If each batch of pastries uses 2 2/5 cups of flour, the question is exactly how many batches of pastries can the bakery make, right? So basically they're gonna just keep using this 42.5 cups of flour until they run out of it. Each time they're gonna be using 2 2/5 cups of flour. So we're gonna keep using that until we run out. And so if you keep repeatedly subtract 2 2/5 cups of flour, repeated subtraction is another way of saying division. So we can go ahead and write an equation here and say the number of batches, or a number of batches that we can make here, is just going to be how many times the 2 2/5 can fit into the 42.5, right? So if we go ahead and take this 42 1/2, and we divide that by the 2 2/5, that'll tell us how many times the 2 2/5 is going to fit in here. All right, so when we're dividing fractions, let's turn these into improper fractions. So 42 times 2 is going to be 84. 84 plus 1 is going to be 85. So we have 85/2 divided by, and let's go ahead and turn this 2 2/5 into an improper fraction. So 2 times 5 is 10. 10 plus 2 is going to be 12. So we're going to get this 12 on the top, and then we're going to get this 5 on the bottom, okay? Now keep in mind that when we're dividing fractions, we could rewrite all division problems as a multiplication problem. Let's go ahead and keep this first fraction, leave it alone, 85/2, change division to multiplication, and then multiply by the reciprocal of this 12/5, or the flipped version, which is going to be 5/12. All right, so let's go ahead and see what we're going to get here. We can just multiply the tops here. So we have 85 times 5. I'm actually just going to do that on the side here. So 85 times 5, that's going to be, let's see, 25, carry the 2. 8 times 5 is 40, plus 2 is going to be 42. So we're looking at 425 in the numerator. And on the bottom, we have 2 times 12, so that's just going to be 24, all right? So this is how many batches we can make, but that doesn't really tell us a whole lot of information here, right? So I think we're going to turn this into a mixed number. I think that's going to be a little bit more clear. So let's take this 425 and divide it by 24. So I'm going to do that on the side here, 425. Let's go ahead and put that inside the division house and divide that by 24. 24 doesn't fit into 4, but it fits into 42 one time. 1 times 24 is 24. If we go ahead and subtract here, let's see, we're going to have 8 and 1. Let's go ahead and bring down this 5 here. Now 24 into 185. Go ahead and write some multiplication out if you need to, but I think it's going to be 7. I think that's going to end up just being 168 if I'm not mistaken. I think 8 of those would be too much, so I think we're going to go with 7 here. As long as the remainder is less than 24, then I know this is right here. So I'll put a 7 and a 1. So 17 is less than 24, so we know this is correct. So as a mixed number, this is going to be 17 and 17/24. So the question does say exactly how many batches we can make. So we can say that they can make exactly 17 and 17/24 batches. Or more likely, they're going to make 17 of these whole batches and just have some extra flour left over. All right, so 17 and 24ths is the exact number of batches, but you can make 17 whole batches, okay? Let's take a look at number 3. For number 3, it says how much candy will 4 people get if they share 2/3 of a pound equally? Draw a picture to support your answer. Well, let's see here. So what each person gets, let's go ahead and write that out. So what each person is going to get is going to be, they're going to take this 2/3 pounds of candy, and they're going to go ahead and share it between 4 people. So we're going to go ahead and divide that by 4. And so if we go ahead and rewrite this, this is going to be 2/3 divided by, and how do you write 4 as a fraction? Well, that's just 4 over 1. Okay. Now again, this is a division of fractions problem, so we can rewrite this as a multiplication problem. So if we keep, then change, then flip, we can see here that each person is really just going to get this 2/3 of a pound multiplied by 1 over 4. And let's see, 2 times 1 on top is going to be 2, and 3 times 4 is going to be 12. I'm not going to go ahead and use the ladder method for the GCF because I think these are just both even numbers. So I'm just going to go ahead and simplify, dividing them both by their GCF of 2. So we're looking at 1/6 of a pound per person here. Now let's go ahead and draw a picture to see if we can make sense of this as well. If that's the case, then this section over here represents the 2/3 of a pound of candy that is being shared amongst the 4 people. So here's what the 4 people are going to share. They're going to go ahead and split it between 4 people. So let's go ahead and create 4 sections here for each of them. Now, while this is what they're sharing, if we want to kind of take a look at what a whole pound would look like, that would be if we extended this all the way. And if you look at this and you continue drawing this whole pattern all the way across an entire pound of candy, you can see that each one of these sections represents 1/6 of the entire pound of candy. And so hopefully you can see here that if you take that 2/3 pounds of candy, which is all of this right over here, and you split it amongst 4 people, which is going to be each one of these sections over here, each person is going to get just 1/6 of a pound of candy, or 1 out of 6 pieces of the entire pound. So this one little piece right over here represents what each one of those 4 people are going to get. All right, let's check out number 4. In number 4, Mr. Mount has 9 yards of string. He wants to cut it into 3/4 yard length pieces. How many of these identical length pieces can Mr. Mount cut? Draw a number line model to represent the situation and support your answer. All right, so to figure out the number of pieces, we're going to take the 9 yards of string that Mr. Mount has, and we're cutting it into a bunch of these 3/4 size pieces. We're going to divide it and see how many times we can fit this inside of that 9 yards that we have total, right? Now, writing 9 as a fraction, it's going to be 9 over 1, and if we're going to divide this by 3 over 4, we can just rewrite this as a multiplication problem if we keep and change and flip this. So we're going to keep the 9 over 1. We change the division into multiplication, and we're going to flip this 3 over 4 to make it 4 over 3. So if we multiply that 9 times 4 on top, that's going to be 36. And if we multiply 1 times 3 on bottom, that's going to be 3. And 36 divided by 3 is going to be 12. So from that, we can say that Mr. Mount can go ahead and cut 12 of these identical pieces, and each of them are going to be 3/4 of a yard long. But let's go ahead and see if we can draw a number line model to represent the situation as well to see if it makes sense. So here I just went ahead and sketched a number line where the 0 through 9 just represents all the 9 yards of string that we have. And because we're going to be cutting the yard into 3/4 size pieces, let's go ahead and divide each of these into quarters. All right, so now each of these are broken into quarters. We can see how long each of these strings are going to be. So the first one's going to be 3/4, which is from here to here. Another 3/4 would be from here to here. Another 3/4 would be 3 of these little tick marks right over to here. Another set of 3/4 of a yard would be right over to here. Another 3/4 to here. Another 3/4 to here, and then to here and to here. And then 3 more would be 3 of these, then 3 more of those, 3 more, and then 3 more. So each of these would be the length of 3/4 of a yard. So how many of these could we fit inside here? Looks like we could fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So looks like we were able to cut 12 of these 3/4 yard length pieces. So on top, each of these numbers represented the yards. And on the bottom, these numbers represent the number of 3/4 yard length pieces of yarn that are going to be fitting inside of the 9 yards that we had to start with. All right, so there you have 4 different practice problems on testing your ability to use what you've learned about dividing fractions in a few different application scenarios. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.